Hello everyone and welcome to day 3, second video, but day 3 of notes where we're looking at transformations. And in class, already on page 14, we looked at how the beginning of the translations works. So we graphed an absolute value, and then we looked at how these two functions compared to the original absolute value. And if you weren't here, you can get notes from someone on that. So if we look at this idea of how something moves, there's a difference. There's something that's being added or subtracted to the outside of the original function versus something that's being added or subtracted to the inside of the original function. And if it's being added or subtracted to the outside, it's separate of it. It moves it up or down, just like you would think. Plus k moves it up k units, and minus k moves it down k units. If it's on the inside, anything on the inside is opposite of what you think. And therefore, if it's a positive k on the inside, it actually moved it left, and it's moved right if it's a negative k. So when we look at example 2 here, we have f of x. This is what f of x is. We have what f of x is right there in black. It's asking us to now graph f of x minus 3 plus 1. So since plus 1 is on the outside, we move it up 1. And since minus 3 is on the inside, we moved it right 3. And so what we're going to do here is now move everything up 1. I don't need you to move every point. Watch what points I use. That's a nice point. That's a nice point. Nice point, nice point, nice point. So we're going to be moving 5 points. So we're going to be moving this up 1, right 3. Up 1, right 3. Up 1, right 3. And when I go to regraph this, if it could be straight, it should look almost identical to the original function, just moved. And so in part A, it says, what is the value of g of 0? Well, there's two ways to do this. One, I graphed it, and g of 0 is when the x value is 0. So I want to know the y value. So g of 0 equals, well, I go here, up 2. So g of 0 equals 2. Or what you could have also done is said that g of 0 equals f of 0 minus 3 plus 1. Well, what was f of negative 3? F of negative 3 was 1, 2, 3, 1. Plus 1 is 2. So I know that was 1 plus 1, which equal 2. Both will give you the same answer. One way, you plugged in 0 to begin with for x and used the original function. The other way, I already did the transformation and then found the actual answer. So when we look at maybe just the domain, you don't need a graph for this. Maybe a graph would help, but you don't need a graph for this. A function f of x has the domain negative 3 to 10, meaning that you're at negative 3 and going all the way to 10, and a range of 22, less than 22, already going down. So what does this positive 10 do? This positive 10 moves it down 10. So instead of being at, up 10. My fault there. Up 10. So instead of being at 22, we're now at 32 and going down. And what does this positive 7 do? Moves it left 7. And so therefore now negative 3, if I move it left 7, becomes negative 10. I moved it left 7. And this 10, I move it left, becomes 3. Now I'm only looking between the green. The gray doesn't matter. And so what is my new domain? My new domain is negative 10 less than or equal to x less than or equal to 3. And my range is now y is less than or equal to 32. So I visualized it right here, moved everything left, moved everything up, and now I have my new visual of what my domain and range are going to be. If you could do that in your head, that's perfectly fine too, but visuals are always nice. So now instead of using f of x, we're using an actual function. This is the quadratic function. You should remember that from last class where we went over all the parent functions. How has a simple quadratic x squared been shifted? So you look right here. Here is your x squared. What's inside, there's your squared, and what's the outside. So I know what's on the inside is minus 4. Therefore, we've shifted right 4, because that's on the inside. And this minus 5 is on the outside, so I've been shifted down 5. So given that the original function has the point 0, 0, where is the new point 0, 0? Well, if I shifted right forward, so if I'm at 0, 0, and I shift right 4, I'm at 4 here, and down 5, I'm down 5. I mean, that should be on the line. I understand that. Down 5, I know I'm at positive 4, comma, negative 5. Positive 4, down 5. Then it says sketch f below and give the domain interval over which f is increasing. And then which one has a lower minimum value? Well, let's just do D right now. D has a minimum value if we know the original parent function looks like that. If I know I was moved right 6, down 10, I know I'm at 6, comma, negative 10. If this is my turning point that we're going to graph here, which one has the lower minimum value? Well, if I have to graph this right here, 1, 2, 3, 4, 1, 2, 3, 4, 5, and then we're going to which one has a lower minimum value? Well, you should see that negative 10 is lower than negative 5, and therefore g of x has the lower min value. Again, if none of that made sense, please pause it, rewind it, and watch again, please. I'm going to do exercise 5 with you A, and then you're going to try B on your own. So I'm given f of x right here, and I need to graph g of x. And the only thing that happened to g of x, is that it was moved right 2. So again, I'm just going to move the main points. I can graph everything else. Right 2. It says show that the zeros are negative 1, bingo, and 2. I did it. Okay, and so that's all it is. I want you guys to try B. So pause it, try it, and I'll come back with the answers. And just so that you can see something here, I could have not graphed this at all, and also have found these. Negative 3, if I plug in negative 3 and I get negative 3 minus 2, and I'm looking at negative 5, if I go over 1, 2, 3, 4, 5, it's also negative 5. If I plugged in 0 here, f of 0 minus 2, that's negative 2. I go over negative 2, 1, 2, go up 3. So you could have used the green graph, found just g of negative 3, 1, 2, 3, and gone down, and used the points on the green graph for g, or I could have plugged back in here. On to reflections of functions. Looking at exercise number 1, we're going to look at what a negative on the outside of the function does. So if we look here, g of x equals negative f of x, right here. And we have the graph already drawn for us. So if we look at g of x equals negative f of x, so if I plug in 0, g of 0 equals negative f of 0. So my new function g of 0 equals What is f of 0? I already wrote the points down. 5. So f of 0 is 5. Now if I negate it, it becomes negative 5. So my new point is 0, negative 5. So if I go here and I go 1, 2, 3, 4, 5, this is my new point. And what about g of 1? G of 1 equals negative f of 1. Well, f of 1 was 0, so that doesn't change. So I can keep that point right there. It's still 0. But let's try g of 3. G of 3 equals negative f of 3. Negative f of 3 was actually a positive 3. Just 3. And what you should see that happens is what kind of reflection? And this point now is down here. This point is now up here. What did it reflect over? And hopefully you got that it reflected over the line y equals 0, or how we usually say it, reflects over the x-axis. And I'll finish drawing the rest of this. Negative 4 is created to be a positive 4. 0 can't be reflected. And so when you graph this, it's flipped upside down. And hence, it was reflected over the line y equals x. Sorry, take that back. Reflected over the x-axis, not the line y equals x. X-axis. Now consider the function h of x equals f of negative x. So in this case, if I have, let's go to a different color here, f of 0, sorry, g of 0, let's try that again, h of 0, what that's saying is that's really saying f of negative 0. Well, can you do anything to negative 0? And the answer is no, so we know that h of 0 still equals f of 0, which is 5. And let's try f of 1. F of 1, sorry, h of 1 equals f of negative 1. Well, I don't have negative 1 up here, so if I go to the original function, I can go up there, plug in negative 1, and you would actually get 12. So h of 1 equals 12. So we realize that if I go h of 2, I can't find negative 2 unless I use the graph. So let's do this. Let's find h of negative 3. Well, if I find h of negative 3, we know that's f of positive 3. Oh, we have that. That's equal to negative 4. And so what you should be seeing here is that if I try to graph, I'll use blue, h of negative 3, it was actually 1, 2, 3. That was actually 4 right here. And what about h of negative 2? Well, that's really f of positive 2. That's here. And you should start to see that this is going to look like that. And what happened to this graph? Well, instead of being reflected over the x-axis, this was reflected over the y-axis. And so, if this does not necessarily make perfect sense to you, keep going out and trying different h of negative x values that you have on this graph. So h of negative 4 would really be f of positive 4. So today we talked about transformations that move the function up, down, left, right, and reflect. In class, we will finish up exercises number 2 and 3. So enjoy your day, and I will see you in class.